Welcome to The Explainer. Today we're tackling a question that is so fundamental you might think you already know the answer. And that is, what is everything really made of? I mean, the world around us feels solid, it feels real, but what if that's just, well, an illusion? Let's find out. Okay, think about the chair you're sitting on right now, or the desk your computer's on. Feels completely solid, right? Of course it does. But what if I told you that, on a microscopic level, that chair is almost entirely empty space? We're about to see the proof.
So, to get to the bottom of this, we first need to get on the same page about what we're even talking about. Scientists have a specific name for all the stuff in the universe, and that name is matter. And the definition is beautifully simple. If something has mass and it takes up space, guess what? It's matter. That covers everything from the obvious stuff, like stones and the food we eat, to the less obvious things, like the very air we're breathing or even a single drop of water. It's all matter. Now, for a very, very long time, great thinkers were completely split on what matter was really like. And this disagreement created a central mystery that science just had to solve. Was the universe kind of smooth and whole, or was it something else entirely?
So, two big ideas emerged. The first was that matter is continuous. Imagine a perfect, unbroken block of wood. Smooth, solid, no gaps. The other idea was that matter is particulate, made of countless tiny individual pieces, kind of like grains of sand. So which is it? A solid block or a pile of sand? To settle this, we got to look at the evidence.
All right, our first clue comes from a super simple experiment, one you could probably do in your kitchen right now. All it takes is a glass of water and a spoonful of salt. And believe me, it has a very surprising result. The setup is really straightforward. You take some water, you mark the level on the glass, and then you stir in some salt until it just vanishes. The key here is to watch that mark on the glass very, very closely. And here is the mystery. After you stir it, the salt has completely disappeared, but the water level hasn't gone up at all, not even a little bit. Now, if water were a continuous, solid block, adding more stuff to it should make the level rise, right? But it didn't. So, where did the salt go? And this is our first huge clue. The salt didn't actually disappear. The only way this experiment makes any sense is if the water isn't a solid block. It has to be made of tiny particles that have empty spaces between them. The salt just broke apart into its own tiny particles and slipped right into those gaps. This is our first real piece of evidence that matter is particulate.
Okay, so we've established that matter is made of particles with space between them. But honestly, that just opens up more questions, doesn't it? Like, how small are they? And are they just sitting still in those spaces? Well, our next clues are going to reveal an invisible world that's in constant motion. This next experiment is designed to really test the limits of these particles. We take just a few tiny purple crystals and dissolve them in water. Then we take just a small amount of that colored water and dilute it again. And then we do it again and again. The result is just astonishing. Even after diluting the solution over and over and over, the water still has a little bit of that purple color. This can only mean that those few original crystals must have been made of millions and millions of tiny particles. They are, and this is really the only way to say it, small beyond our imagination.
So we know they're incredibly tiny, and we know they have spaces between them. But are they just stationary? Think about it for a second. How can you smell food cooking from another room? Or why does the scent from an incense stick eventually fill the whole space? The particles must be moving. This movement, this constant jiggling, is driven by something scientists call kinetic energy. And when particles of different things mix all on their own, like the smell of food mixing with the air in a room, that process has a name. It's called diffusion. And it's happening all around us all the time.
And temperature plays a huge role here. If you drop a colored crystal into cold water, the color spreads out very slowly. But in hot water, whoosh, it spreads much faster. That's because heat gives the particles more kinetic energy, basically a turbo boost, making them move and mix way more rapidly. This is exactly why you can smell hot, sizzling food from much farther away than you can smell cold food.
Okay, but this leads us to a final and absolutely crucial question. If all these tiny particles are constantly moving around and they're separated by empty space, what stops everything from just flying apart? What's holding your chair together? To get this, just imagine a human chain. Trying to break through a line of people who are locking arms is going to be incredibly difficult. Now, if they're just holding hands, it's a bit easier. And if they're only just touching with their fingertips, the chain breaks almost instantly.
I mean, the answer seems obvious, right? It all comes down to the strength of the connection, the grip, between each person in that chain. And it turns out, the very same principle applies to the particles of matter.
And that brings us to our final piece of the puzzle. Particles of matter attract each other. There's an invisible force acting between them, sort of like a glue that holds them together. The strength of that force is what makes a rock and not just a cloud of dust.
So, our mystery is solved. We started by asking what matter really is. And now we know. It's made of particles that are just unbelievably small. They've got empty space between them. They are in constant restless motion. And yet, they are held together by an invisible force of attraction.
And this brings us right back to where we started. That chair you're sitting on? It isn't a solid, continuous block at all. It's a vibrating, dynamic collection of countless tiny particles held together by invisible forces, and it's mostly empty space. So the next time you touch something that feels solid, remember what's really going on beneath the surface. What does solid even mean now? That's something to think about.